Hello, everyone, and welcome. Software engineering is changing, and by the end of 2025, it's going to look fundamentally different. In 2021, we announced our first model that we called Codex. This was the first time that we've really demonstrated what we would now call vibe coding. Just a couple weeks ago, we released Codex CLI, which is a local agent that runs on your laptop in your own terminal that you're able to pair with and interact with in a synchronous fashion. Today, we're going to take a step towards where we think software engineering is going, and we are releasing a new system, which is a remote software agent that can run many tasks in parallel. We call this system, in the grand tradition of OpenAI naming, Codex. The thing that is exciting about Codex is that it runs with your repository, your environment on OpenAI compute. So you're able to run many, many copies of it. So you're able to do many tasks in parallel, fire them off, come back to them later, which is something that we'll be showing you today. We're rolling this out to ChatGPT for Pro, Enterprise, and Teams users starting today. And we will be following up with Plus and EDU in the future. Codex is powered by a new model that we call Codex 1. This is our best coding model to date. We've taken O3 and we've optimized it for not just the benchmarks, but really for the kind of code that people actually want to merge into their code base. So thinking about comments, thinking about extraneous changes, thinking about the style, so that it's something that actually really accelerates people's work. And so to show you this system, which we're so excited to share with you, we have many members of the Codex team.
Hey, I'm Hanson. I'm one of the members of the Codex research team.
I'm Josh, and I'm an engineer on the Codex team.
And I'm Thibaut, and I built code agents and the infrastructure to power them. I'm going to be jumping right into the demo. So normally, you would have to connect your GitHub account. I've already done that for myself. And here I'm going to be selecting my repo. I have selected an open source repo, the preparedness repo, which contains some of our frontier evals made by the amazing preparedness team that we have here. And this is relevant, like frontier evals are really about agents. So I'm just going to be using that environment. And then I'm greeted with 3 tasks that we believe are good to get started with on any repo. The first one is an ask task, which just asks the code agent, Codex, to explain the code base to a newcomer, explain the general structure. The second one is a code task, which asks to find and fix a bug somewhere in the repo. Most of the repos, as you all know, have bugs. So let's see. Let's see if the Codex agent can find one. I did not put any bugs in there. This is code that we work with every day. And so we're going to be showing 2 repos today. One is the preparedness repo, and the other one is the Codex CLI one. And the final one is one that I'm really excited about, where I ask it to go through the code base and not just explore the code base, but also come up with proactive task suggestions that it could be doing on its own. So let's start those. Now we have 3 Codex agents working on these tasks concurrently, just in the background. And what I'm also going to do is, one of my favorites is find as many typos and grammar mistakes as you can and fix them. I think this didn't matter. Let's see if it understands also that my instructions as I make typos. And I have scheduled a task just before this, before we were going to jump on this, where I asked something quite interesting to the Codex agent. I ask it about one of my goals. I say, my code base I want it to be maintainable and bug-free. Read through the code, propose some tasks that would help with this goal, and don't overemphasize on to-dos. Like, to-dos are everywhere in code bases. Those I know about. I want novel things. And so the Codex agent went through the code base, and in its little environment, as we're going to show you, it found out about multiple things. Let's have a look. One of them here looks like we are having mutable defaults as arguments. Let's have Codex fix that.
Definitely fix that.
So let's schedule that. Correct variable spelling. I believe this will get fixed as part of the other task, but let's schedule that anyway. And then here, there was a little consistency about how we set timeouts. One time, we set it to 120. Another time, we set it to 60. This Codex agent here has proposed a task for itself. So we are delegating the delegation here, which blows my mind every time. And I'm just going to say make it 120. I think this is the right timeout here. And let's have it code out for us. And then let's jump into maybe this task here and see the Codex agent at work. So this isn't running on my laptop here. What exactly is going on here, and like how does this work?
Yeah, that's a great question, Devo. So as evidence from just seeing all these tasks launch in parallel, we now need new agentic coding infrastructure for this world where agents need not only their own GPUs, but also a couple of CPUs. So this runs on OpenAI's compute infrastructure. It's actually, in fact, the same infrastructure we use for our reinforcement learning, and which means, fortunately, even ahead of this launch, it's been battle tested on the large-scale training runs that we do. And crucially, it's also consistent between what the agency is during training and what the agency is later in production. So each of these tasks runs in its own micro VM sandbox, own file system, CPU, memory, network policy, and the agent has free reign within it, right? So the agent has learned how to use all your POSIX commands like grep, sed, knows how to run linting, formatting, and obviously it likes to write and execute a whole bunch of code.
Yeah, one thing that I really love about this interface is just how lightweight it makes it to spin up tasks, right? It's just your task left and right. And I think that really makes a big difference for how you use it.
And I think it's a lot of powerful infrastructure, and like the web interface makes it nice to interface with it, but I think it's also a lot more configurable.
Yeah, so each task runs in what we call environment, essentially more or less a repo, but with environment variables, secrets, and setup scripts configured so that you can customize the runtime to more fully unlock the agent's capabilities. When we worked with early alpha testers, we found that you get really big early wins by installing something as simple as a linter or a formatter. And we actually now install a lot of those by default. And of course, our power users have all their test dependencies set up. For OpenAI's internal environments, we have even pre-commit hooks set up. So as the agent's coding, it's actually committing, seeing what the commit hooks say. Really similar to actually my own dev environment.
That sounds really exciting. Maybe let's watch it work. And we're going to jump to an environment that we have fully configured, like the Codex CLI, and let's demo something cool with it.
Yeah, so I think one of my favorite use cases for Codex is its ability to find and resolve complex issues. So even leading up to this launch, I think Codex actually found and fixed a couple of critical bugs in our code. But here we're looking at the Codex CLI, which Thibaut and I have worked on. So we've got a bug report from a user here. Basically, when they have file names with special characters, the diff command in the CLI shows up with an error message. And so one of the things we've trained our agents to do is not just like address these issues, but also we've introduced this concept of an agent's MD file. So we know for developers it's extremely important to provide steerability and instruction to the model. And so the first thing we'll see it do here, it'll actually take a look at the agent's MD file in the repository. And so here we've provided some instructions about the layout of the repository. You can see one of the special instructions here, we've asked it to print some ASCII art to the terminal. I think, does that look like a cat to you guys?
It is.
It's a different cat every time.
It passes my cat test.
Yeah, pretty good. And then I think we also saw above that, basically, we've also told it, here's the TypeScript part of the repo in the Codex CLI. And along with some instructions about how to run tests here, which is pretty important for the agent. So one of the cool things about the way we train these models with end-to-end reinforcement learning, they not just write code, but they also know how to navigate the code base and even reproduce the issues. So here, it's written a little script for itself. So you can see it's similar to us. I don't know about you guys, but I love to use print debugging.
No.
Never.
That's something we see emergent kind of as part of the RL training. It actually wrote a little script here to reproduce the issue. It's written a file actually that matches the user's description, and it's actually able to execute the code to actually verify that the issue's able to be reproduced.
It's displaying a lot of complex behavior that is very similar to how we all work. How do we teach the agent to do that?
Yeah, I think so. We have a lot of these kinds of tasks in training. We use end-to-end reinforcement learning to actually verify that it completes the entire cycle from writing code to running tests, and then we verify that that it actually is able to complete the tasks and satisfy, for example, both style checks and programmatic checks, and many other things. And then we can see that, on evaluations like Sweetbench, this results in state-of-the-art performance. So it's actually, we can see here it's actually found the issue, and it's actually writing a test for itself now so we can see that it's verifying its work for us. And it's almost done here. So it's actually, now it's even running linters to verify that the code is matching our style expectations.
And I saw it refer back to its agents.md here.
Yeah, exactly. So as part of the agents.md, you can provide detailed guidelines on, for example, like commit messages and PR messages and how exactly you want your code to be structured.
It looks like it's preparing files for commit.
Yeah, I think it's almost done. So just within, like the time that we spent talking, this change probably would have taken me, like at least 30 minutes or even hours to debug, and just in a moment, I think we'll see the final PR.
And the other thing is you could do this from your phone.
Exactly. Yeah, it looks like it's done with the PR. How's this look to you, Thibaut?
Let's have a look. It's kind of tricky to review code so fast here, but one of the things here is that it did add a test. It's a repro test for the issue that we mentioned. So this seems to match here. And also what gives me confidence is that it actually ran this test. And there is like a little proof here, which we'll talk about later, where I gain a lot of confidence here that this test is actually passing. So I would just go and like push and create a PR here. But now that we have a whole bunch more tasks to have completed, what do you think, Greg?
I mean, I think this is magic. I'm definitely feeling the AGI here. Thank you all. And I think that what this system, in my mind, shows is that we're moving beyond thinking of our AI systems as just language models, right? That we're really building systems around them. So it's not just about the core AI intelligence. It's really about what tools it has access to, the environment that it is able to operate within, the kinds of sort of real world, conditions that it's been trained to be exposed to. It's starting to feel much more like the interface that we're going to see for a real AGI. Still much more to build, but it's starting to feel like it has the right form factor. And so here to tell you more about how we build the system are more members of the team.
Hi, everyone. I'm Andre. I work on research and systems for reinforcement learning and coding agents.
I'm Katie. I'm on the research team here.
I'm Jerry. I also work on research here. If we look back at the history, we've been working on large language models that code for many years already. The first Codex models we have released that powered GitHub Copilot and was little more than a smart autocomplete. And I think they have started a revolution of AI-powered coding that we really see take off today. Since then, we've worked on a lot of things. We've improved every layer of our pre-training stack to make our models really, really great at all kinds of programming tasks. At the moment GPT-4 was released, it was by far the best programming model in the world. We've also constantly iterated on our post-training recipe to make the models in ChatGPT really great at answering users' programming-related questions. Every day, millions of users use ChatGPT to accelerate their work. However, working with LLMs on a programming-related projects still feels pretty clunky. It does require a lot of hand-holding and context switching. I believe the current paradigm of scaling up reinforcement learning finally can take us to the place where we can automate larger chunks of work, where our models can work on, where we can tell them what we want to do, not necessarily how, and they can work for extended period of time on that task for a user on a real production code base. Even more importantly, the infrastructure that we are opening up for it is perfectly scalable. It doesn't run on your laptop, it runs on the cloud. At the single push of a button, you can spin up 1 agent, 10 agents, or 10,000 agents. It's an on-demand AI-powered force multiplier. And you are seeing really great results with it internally.
Cool. So I get to do the part of the demo that is probably the most unlucky, where I'm not going to kick off any tasks, but I am going to take a look at the tasks that Thibaut, Hansen, and Josh kicked off and hope that they're good. And I think this is actually kind of reflection of where engineering work has moved over the past few years, where a lot of my time now is spent reviewing code rather than writing it. And in that sense, it becomes even more important for our models to be very aligned with what we want. So I will talk you through how we train these models with alignment in mind as we look through a couple of these tasks. So let's click back into the one that Thibaut kicked off here. So I think there's 3 key parts here. On the right, we have the actual code output produced by the model. When we look at code and when you review code, you might look for things like, like having sensible changes, doing exactly what the PR description said, and not having extra changes. You don't want extra comments littered throughout your code. This is feedback that we've heard about our models before. And so something that we really focused on was like having good code quality and style so that code is easier to review. The other thing that we really focused on here was interpretability and verifiable outputs. So on the left side here, we have a model-generated summary of exactly what it did. Right here, it added an import for this function. It tells you what it's doing and like why it's doing it. And it shows you in this citation view exactly the code that it was referencing when it's talking about what it did. And then in the testing section, here the model actually ran the test that it was told to run in the agents.md file. But beyond just actually running the test, the model actually reports whether the test passed or failed. And in this case, you can see exactly where in the work log the test was run, and you can see and verify that it succeeded. Let's take a look at one more task. OK. So here, there's another task that was done in the preparedness repo where I can take a look over this model output, and it might pass like the smell test to me initially, but I can see from the model's testing output here that it actually didn't manage to pass the test. And so I'm looking here, and it looks like it might be something with like a missing dependency in the environment, maybe Pedantic's not installed. And so this PR might be something that I check back out to my computer and rerun the tests locally. And maybe if I see that this is valuable, this is something I can go back to my environment configuration and reinstall. And ultimately, I think we find Codex to be like as trustworthy, if not more trustworthy, than our own coworkers. I don't have this kind of access to like what Andre did on any given day in terms of like the logs or the actual test outputs. And I think as we move towards this world where AI writes more and more code, this kind of verifiability is going to be really important.
So I'm super excited to share this with all of you today. I've been working on this for more than 2 years, actually a lot of that time with Jerry. It's been a real blast. And we've been using this internally and seeing a lot of really magical moments start to appear. We're sharing this with you today because we think this does represent a glimpse into the future of how software engineering is done. I'm just going to tell you a little bit about how I use the product. So in the lead up to this launch, I've ended up doing a lot of coordination work. I haven't had as much time for coding as I may be used to, or as much as I maybe ideally would like.
Sorry.
Maybe Greg can empathize with that a little bit. And so if I'm like reviewing someone else's code or reading through Slack or playing with the product just to make sure that it's developing well, sometimes I'll have an idea of like a code change I might like to make, a change in the product or some refactor, and I'll just kick it off in Codex. It takes like 30 seconds. It's a very lightweight thing to do, and then I'll go back to Slack or wherever I am. And then later I'll come back, and the task is sitting there, and it's done. And sometimes it's a small task. It's like a simple string change. Sometimes I was ambitious, and I put in a request for like a bigger refactor or some sort of feature. And this by no means works all the time. This is a research preview. We think it's still early days. But sometimes it's like a multi-hundred-line diff, and I open it, and I start reading through it, and I'm like, wow, this actually looks like it's correct. And I read through what the model did. Maybe the model ran some tests. Maybe those tests failed, and the model fixed the test failure. I look on the left, and all the little test results are green. And I'm like, this change actually looks really good. Let me open a PR. Maybe I'll send it to a colleague for review. Maybe they'll approve it, and we'll merge it, and it lands in the code base. And then I take a step back, and I realize I just landed like a non-trivial change, like a large change, often, in our code base, and that branch never even hit my laptop. It was just something that happened completely through this interaction with an async delegation to one of these agents. And when that works, it's really a magical moment, and it's really amazing. And when I talk to other colleagues, they're using the product too, and they're using it in different ways. And they're having magical moments and magical interactions with it of their own. And you can see some of those stories in the videos that we're linking from the blog associated with this release. So that's all very exciting to see, but what I'm most excited about is to share this with all of you today and see what you all do with it.
One of the things that I find really exciting about how Codex works is it has very non-human strengths and weaknesses. And so it really means that you get much more out of it if you start thinking of it as not just a static tool that you just use like, just without having to build expertise, but if you really optimize your code base around what it can do, you start, like, honestly, most of what Codex benefits from is just what is good software engineering practices in terms of modular code bases with good tests and things like that. You're able to just move so fast, and we've seen that happen internally with many people at OpenAI. We are releasing this today to ChatGPT enterprise teams and pro users. We're going to have very generous rate limits. We're going to start out without any additional pricing. Over time, as we start to get some feedback and some sense of how people are using it, we'll introduce more rate limits. We'll be rolling out to Plus and EDU users that we'll be thinking about if there's pricing for how to get additional queries. In general, we're just so excited to see how people use it because we've seen every single person at OpenAI uses Codex differently. Now, we're not nearly at the end of this journey. We're very much at the beginning. That we're going to continue to improve Codex. We're going to make it be integrated into far more systems, like be there in your issue tracker, release an API so that you can have it automatically be integrated into your CI. So if there's a CI error, you don't have to fix it anymore, that Codex takes care of it. We also are continuing to develop Codex CLI, which again is a local agent that runs on your laptop. We're releasing a mini model today, and we're also going to be releasing sign-in with ChatGPT to make it easier to get up and running. Now, if you think about it, there's two different form factors that we've talked about. There's the local synchronous on your computer version, but there's also what Codex is of an asynchronous in the cloud, runs on its own computer. And we think that the future is going to be these two systems coming together, right? What you really want is you want a remote coworker with its own computer, but who can also look over your shoulder. And so you're there typing away, you're working on some change, you're like, I want to go to lunch. Codex, can you finish this? It just takes it over seamlessly and runs it in the cloud. Or if you have a question about something or you want to pull down a change because your dependency isn't installed or something like that, it all just moves around totally seamlessly. So it's a coworker, it's a intern that you can delegate to, it's a mentor, it's a pair programmer, and all of these at once. And so our goal really is to help accelerate the useful work that is done to help it be so there's more software engineers in the world, so that there's more programming that is done that is useful and able to move forward the world. So we're just so excited to see what you're going to do with Codex. Thank you all.